So let me just do a little bit like explanation on like how what Starknet is all about. So I know most of you here are developers, and maybe you have like some technical background on how crypto works and a whole lot of other stuff, right? Well, first off, how many people know what the blockchain trial is all about? Because I'm going to explain why Starknet is important and why you should actually pay attention to what is doing in the crypto world. So how many people know about blockchain trilemma here? Okay, cool. So basically what the blockchain trilemma means is that like both decentralization, security, and scalability can exist on a specific blockchain, right? So this is actually an issue Ethereum like have had like it still have it actually like it's secure, it's decentralized, but it doesn't have like the capacity to scale to a level that would be okay for mass adoption, right? So over the years, if you actually like in the 2021 crypto maniac, you would oh, you can't hear me. Can you hear me?
Sure, we can hear you very well.
Okay,
We can hear you
yes.
very well.
Someone was saying that they can't hear me. So it led to different ideas coming up. Okay, how can we actually like scale the blockchain? They were like ideas like plasma, they were like sidechain, if you know about like Polygon. But then all those were not sidechain is actually efficient, but layer two actually get to inherit the decentralization and security of the layer one blockchain, which is Ethereum. So that's how the idea of rollup came about. So for Ethereum, when like let's say Ethereum, how it works, it kind of like process one transaction like at a time. So which is why it's slow because and also like each validator on the Ethereum network has to like verify this transaction like one by one to verify that it's actually accurate. But on Starknet, the case is completely different because what it does is that when let's say the validator like want to verify this particular like new state or new transaction or as the case may be, there's already like a proof for to say, okay, this is actually like correct. You don't have to like raise it like all over again, just like you do on Ethereum, which makes Ethereum to be to consume more computational power, right? But then on Starknet, like it's very, very easy. And just like the idea of rollup, right? Whereby you know that okay, when a lot of people do this transaction, what rollups do is that they get to like bundle this transaction, then send them down to the layer one, which is the verifier to verify that this actually like okay, right? So yeah, that's basically like the idea of layer two. But what makes Starknet very unique is that it comes with a whole lot of other features like Starknet like has native account abstraction whereby you have session keys, you have two-factor authenticator, you have multi-cores. So if you are like in crypto or even right now on Uniswap, you have to sign, you have to approve, you have to do like 3 steps of transaction before you actually like get to swap your token. But then on Starknet, all you just need to do is swap. I mean, you don't have to because of the feature of multi-core. So the same also there are other features like session keys. So if you're a gamer, you want to like try out like games on Starknet, unlike let's say on Ethereum, whereby you have to sign every action you make. Imagine when you want to like hit someone on the game, you have to like sign, okay, approve, approve, approve to actually like, or maybe you have to like sign all this transaction like every time you want to do it. But on Starknet, when you enable session keys, it becomes like very smooth. You just have to like sign this just once and everything like works fine. Same with I mean there's also like two-factor authenticator, just like what we have on um all these banks. I mean, you have like all these things to secure, even on Binance to secure your wallet. So right now, like if you set up an agent wallet and you have 2FA on it, no one can actually like access it, or maybe unless if they have like access to your 2FA, right? So there's also a lot of other features like that makes Starknet so unique. And I hope at the end of this bootcamp that a lot of you will actually get to understand um why Starknet, why you should actually like pay attention to this ecosystem, and why you should be very interested in Cairo. So what I basically tell people when it comes to learning Cairo is that, I mean, it's unlike let's say Ethereum and some other ecosystem. the space is not like saturated like every other place, right? I mean, you can get to learn Cairo, be very good at it, and you'll be a standout like developer in the ecosystem. So this is actually one of the major advantage, and also there's platforms like Only Doors whereby you can contribute to. I mean, you don't even have to be employed to contribute. You can just like contribute to any open source project. Then there's also the opportunities that you get to like meet on the way, like when you start being in the Starknet ecosystem. So it's very amazing. And I hope that this first class, which is all about like getting to know about the Starknet ecosystem, whereby you get to like learn about what layer 2 is all about, what Starknet is all about, and the overview of Starknet, the architecture, and how actually it works under the hood. I just hope that everyone would pay attention to this and grasp the huge potential that like Starknet has. Yeah, thank you.
Yeah, Paul, thanks so much for that brief um, explanation of the Starknet ecosystem and the opportunities that we have in this space. I don't know if anyone has a question for him. If anyone has a question, Goltong, see your hand up. Okay, Chinoso, yeah.
Okay, it's Starknet a layer 2 because I think I came in a bit late.
Yes, Starknet is a layer 2. So how it works is the layer 2 settles on the layer 1. So Ethereum is a layer 1. Then every other layer built on top of it is a layer 2, which Starknet is a layer 2. Or you can just call it like variety rollup. So variety rollup in the sense that for every transaction like that goes through it creates a proof for it, and there's also a lot of like other features that okay, just like okay, let me just not go deep because this first class we actually like cover most of this in the Starknet overview.
Yeah, and we'll actually cover everything about Starknet in the next 5 weeks, and we are hoping that good projects, right, will actually come out of this bootcamp. Thank you very much. Yeah. So okay, so we'll start our first session, right? Our tutor is already here, and so we'll start ASAP. And meanwhile, there are some few things which you guys have to know. So during this bootcamp, right, we'll be giving you guys some few assignments, few projects to complete, and the criteria for completing this bootcamp is you must have attended all the classes. Our classes are just they are twice a week only, Mondays and Wednesdays, right? Then we'll be taking attendance as well. Thank God that the call is being, so if you think you can actually come and join and leave at the first instance, right? You are doing yourself really. Then you must have actually completed your assignment as well. On the last of the bootcamp, those that have actually met this criteria, you will submit your Starknet wallet address. I think, not that I think, we are going to drop you guys. I think like an NFT, which will be useful like in the future. So, Amanda, good evening.
Yeah, good evening, sir. Good evening, Mr.
Yeah, the floor is all yours now. You can start.
Okay,
Yep.
cool. So, good day, everyone. Trust we are all doing fine. Sorry for coming late, and I couldn't join the introductory section real quick. But I came in and I saw Mr. Paul is already doing justice to ZK. So, I'm sure the class have already gone far. So, I can't hear from you guys. Can I just see your emojis so that I know that we are together and everyone can hear me?
We can hear you very loud and clear.
All right, cool. So,
Yeah.
welcome to today's class. So this class is a prerequisite to, I would say, Ethereum. For all of us who have knowledge or who have been building on Ethereum, I would say this is going to be like an interesting session for all of us. And then if you haven't, or if you haven't built on Ethereum before, I will advise you try to catch up as fast as possible because Starknet is an interesting ecosystem. And then there are a few things that make it related to Ethereum, and then there are a few things that make it different from Ethereum also. So in the course of learning, we should be able to differentiate both. So if you have been building on Ethereum, you have to like get used to new terminologies and then similar terminologies with what you've been learning before, right? So let's just head over and get started. So before we say anything, what is Starknet, right? That's the question. And then I want to believe that a lot of people have been, a lot of you prior to the boot camp have already been searching about Starknet, right? Since you got the invite, everyone wants to know what's Starknet first. And then you must have done all your underground study. But before we go anywhere, what is Starknet? So let me just share my screen and then I'll show you this slide. Then we are good to go. Okay. Sorry, I'll be with you shortly. All right, cool. Can you all see my screen? Cool. So we are good to go. All right. So first things first, what is Starknet? So as you can see on your screen, Starknet is a permissionless layer 2 scaling solution for Ethereum. So we ask ourselves the question, why do we need to scale Ethereum? If you can be able to ask yourself that question, you will be able to understand why we need Starknet and then what is Starknet. So first and foremost, before we go deep, what are layer 2 solutions? So let's highlight this. I think that should be the first thing we should ask ourselves. What are layer 2 scaling solutions? So there's a problem with all blockchains, right? And then that problem is popularly known as the trilemma problem. So if you know about this, you know what I'm talking about. But if you don't, I will advise you just Google search what is the trilemma problem that the blockchain faces. So the blockchain is like a triangle, right? And then there are three parts to the blockchain, which is one, decentralization. And then the second is someone raising up their hands? All right, cool. Let me proceed. So first and foremost, the trilemma is just a triangle, right? That every blockchain needs to have. So it's three basic things. First and foremost, it has to do with decentralization, which is like the order of the day that everyone is here to talk about. And then why we are even doing Ethereum in the first place. So every blockchain needs to be decentralized. That's first. Now, the second part of the triangle, the second phase is that every blockchain needs to be secure. Why? Because everything is open and free to everyone to see. And then lastly, every blockchain should be what? Scalable. Because why is it supposed to be scalable? Because it's a new technology, and then a whole bunch of people are going to be on this network sooner than we all can imagine, right? So currently, when they are building Ethereum, they are building it like on a normal scale, like to support the current technology, right? But in later times, we are expecting like 1 billion users and less. So every blockchain needs to maintain like these three features, which is decentralization, security, and also scalability. Now, Ethereum is able to just have like two of this, which is decentralization and security. And then that's the popular trilemma problem. So the problem is that these three features that I mentioned, no blockchain can be able to implement like all the three. So it's mostly just two of this. So it's either the blockchain is left to pick between decentralization and scalability, or decentralization and security, or maybe security and scalability, to leave decentralization out, which obviously is no longer like a blockchain already. So Ethereum chose to pick decentralization and security, right? Which is like the two most important of this. So it is completely decentralized, and then it is fully secured, which is obviously on the sub layer, which is the layer one, right? It is fully secured. And then lastly, these layer twos now take up the last tax, which is scalability. So this is where the word come about of layer two solutions, right? So they are bringing their solutions for scalability. That's why they tell you layer two scaling solution. They didn't say decentralized solution or maybe security solution. What matters on layer twos like Starknet is the scaling for Ethereum, because Ethereum lacks scalability, but it has decentralization and security. So most of us who have been able to interact on Ethereum before, or maybe you have tried to have like one or two transactions on Ethereum, you know how slow it is, number one, and then two, how expensive it is, right? And then that's a huge barrier to onboarding like the next billion people to come on board on this decentralized network. Simply because someone somewhere is currently using his normal Web2 apps without probably even having to pay for premium services, or maybe having to, let's just say premium services for now. And then you are trying to onboard this person to come into the blockchain network and start using Web3 dApps. And then the first thing you are telling the person is, hey, you have to pay for gas. And then this gas, okay, even though the person agrees to pay for gas, how expensive it is, another problem. And then lastly, even after he agrees to even pay for the gas, he now finds out that the network is slow. Is the person still going to be around? No. So there's still a problem that needs to be fixed, which is why layer two solutions are there. And then they chose Ethereum, which is like the first network with programmable dApps on it. And then permit me to say like the best blockchain, right? But since all layer twos are laying on it, so Ethereum is the future. And then let's continue. So what is a layer two solution like Starknet? We've all understood the problem that Ethereum is facing. Now, what does Starknet offer? And then we agree that it is scaling, right? So how does Starknet scale? That is where our first question starts from. So what is Starknet? So let's read now. Starknet is a permissionless layer two scaling solution for Ethereum. It allows developers to create scalable and secure decentralized application, which is dApps. while benefiting from Ethereum's security. Nice. So Starknet bundles multiple transactions together off-chain and then submits a single compressed proof back to the Ethereum mainnet, reducing gas costs and improving transaction speed. Perfect. So this line we just mentioned, I want to highlight on this. So after speaking the lot of gibberish I said earlier, a lot of you questions might be coming up in your head like, okay, now how does Starknet scale? Ethereum was not able to solve the problem. How is Starknet able to do it? Right? So let's see how Starknet does it and how scalability is being achieved on this network. So Starknet bundles multiple transactions together, right? Off-chain. Now, this is what happens on Ethereum. When you submit a single transaction, it gets verified, right? Before it is being added on the network. And then the process of doing all this, if multiple people are submitting these transactions to the network gets slow. Why? Because all nodes have to like verify before it is being added, right? But then in Starknet, how does Starknet do it and how does it achieve scalability? So they bundle multiple of these transactions. So instead of you submitting your transactions to Ethereum, you submit your transactions to Starknet, right? And then Starknet is going to bundle this bunch of transactions. So instead of submitting this transaction one by one, Starknet might bundle, let's say, thousands of transactions together. And then it's going to it's going to do this off-chain, meaning there is no need for paying of gas or anything at all, right? So everything is being handled like cheap by Starknet. And then it submits a single compressed proof back to Ethereum mainnet. That's how Starknet achieved that. So instead of submitting transactions one after the other or one, let's say we have 1,000 transactions, instead of submitting them 1 to 1,000 to Ethereum, we are going to bundle all these transactions into one single transaction and then send it to the Ethereum mainnet. And then it has a proof at the end of the day, which is like one big thing that we are going to understand about Starknet, right? The proof part. Because as builders, we are going to be building with Cairo, right? And then we are going to understand like how powerful the Cairo programming language is. It's simply because of proofs. So when we go deep, we'll understand properly. So this is how it does it. It submits a single compressed proof back to Ethereum mainnet. So with this, it's going to reduce gas costs. So let's say we want to submit 1,000 transactions to Ethereum, and then the cost of gas, let's leave it at 1 transactions, right? But let's use the normal EOA as a benchmark. So let's say the cost is 21,000 gas. So instead of we submitting 21,000 like 1,000 times, or let's just use dollars. So that would be more easier to understand. So take, for example, if the cost of a single transaction, maybe let's say I want to make a transaction on Ethereum is maybe, let's say, $0.5, which we know is more than that. Let's just use $1. So if we are going to submit 1,000 transactions, that's we spending $1,000. Let's use $1 as a benchmark for each transaction. So let's say we are spending $1,000 for submitting 1,000 transactions. How Starknet is going to help us is that instead of we submitting or spending $1,000 to make 1,000 transactions, Starknet is going to take like all the whole transactions and run it as one single transaction. So that's Starknet spending just $1, right? And saving us 999. Isn't that perfect? So with that, instead of spending $1,000, we end up spending $1. So that's the cost part of reducing gas cost. And then finally, it improved transaction speed. So if there are a lot of people on the network gets slower, more slower. That's how Ethereum is. So on layer 1, like Ethereum, for those of you that know, Stack is able to run, let's say, is it 15 transactions per second when it first came through? I think so. You people can just check that out. But then instead of we clogging the network, that is 1,000 people being on the network at once, why not just one person being on the network at that point? So with that, it reduces the amount of heavy load that the nodes have to do on Ethereum, right? And then at the end of the day, it reduces the costs that the user is going to spend on that particular network. So it's a win-win situation here. So nodes have it easy, or the network has it easy. It's not going to get clogged because bunch of transactions are bundled and sent to it. And then finally, the user doesn't have to make like 1,000 transactions and have to spend $1,000. All you just have to do is Starknet will handle those 1,000 transactions and just spend $1 on it, which is completely saving gas costs. So that's why you see today the cost of transaction on Ethereum, let's say an average cost, would be around $4 to $5. But then the average cost of transaction on Starknet, we are talking about 0.001, 0.002 cost of swap max is about 0.05 max in the blockchain network, right? So here I think I've spoken a lot. I should just pause and then listen to questions before I proceed. So no question for now. Can you hear me?
And I think your this thing, your network is actually skipping a bit. Yes, yes, yes. We can hear you now. Your network is skipping a bit.
Oh, sorry guys, I think I lost my network for a bit. Can you guys hear me? Just signify with an emoji. I think Chinoso and Victory have questions. So let's hear from Chinoso and then we proceed and we are good to go. Nice. Nice. All right. So finally, Starknet achieved this in its use of yeah, Chinoso and Victory. Let me hear from you. Else just drop your hand so I know we have I know my question. Nice.
Okay, are you hearing me now? Hello?
Yeah, I don't know whether it's my network or so. I think I can hear you. Yeah, I can.
Not so. Okay. So you were saying something like about from definition,
Yeah, no, so proceed.
Starknet helps to reduce gas. Hello? Hello?
Uh, yeah, I think I can hear you now. Yeah, I can hear you. Speak up.
All right. Can you? Okay. So um I want to ask like the gas, like how Starknet helps to reduce gas. What is responsible for that in particular? Because now, if you write solidity actually consumes a lot of gas. I think from what I've been seeing online, Starknet reduces gas costs. But what is responsible for that reduction of gas costs? Is it the programming language, or is it Cairo programming language that makes it responsible for the reduction of yeah.
Please, I need to be honest, your voice is breaking. I didn't hear your question like fully.
Wow.
Just heard you talking about Starknet helps reducing gas. Can you come again?
Hello. Are you hearing me?
Yeah, I can hear you now.
It's better now. Okay.
Yeah, sure.
I said, what's responsible for making Starknet gas optimizable? What's responsible for that?
Okay, cool. So can you hear me?
Yeah, I can hear you.
I think your question, you're trying to talk about gas optimization. You are a Solidity developer, right?
Yeah.
Perfect. So in Solidity, while writing your Solidity code, the concept of gas optimization happens simply because your logic might bring a lot of cost to opcodes, right? So basically how Ethereum works is it has these opcodes, and then the code you write, your Cairo code, your Solidity codes later on break down to these opcodes, which turn out to become your bytecode, right? And then at the end of the day, the cost of running a single function is going to be determined by those opcodes, right? That's what brought the concept of gas optimization, simply because software developers or Solidity developers, there is high gas cost. So how are they going to minimize this? What they did was, okay, what's a better way to follow when using these opcodes, right? What's a better way to achieve a particular logic using the opcodes with like the minimal cost of gas? That's what brought about the concept of gas optimization. But in the concept of Starknet, I'm not explaining this in the concept of gas optimization. All I'm explaining to you is that this network is fully the cost of gas is fully reduced. That is, how does it do it? Instead of you running like a single transaction or 1,000 transactions on Ethereum mainnet, which is going to cost you like a lot, right? Despite the gas optimization, it's still expensive to run transactions on Ethereum. You are going to agree with that. But then the kind of optimization I'm talking about of gas or money is very, very minimal, or is different from what you are talking about. Simply because what Starknet does is that it handles your transaction off chain, and then instead of you submitting like 1,000 transactions that will cost you, like, let's say each transaction is costing you $1, you are going to submit just one, because Starknet is going to take like the whole thousands of transactions for you, and then generate a proof that this transaction was computed off chain, right? Simply because Starknet does off chain computation. So it generates a proof that says this computation was done off chain, and then it will send that proof to Ethereum layer 1. So now, if the cost of the transaction on Ethereum layer 1 is $1, it will send that transaction for the cost of just $1. But then off chain, it has handled 1,000 transactions for you already. Are we together? So that's how Starknet is able to minimize gas costs. So instead of them charging, let's say, the user, okay, I'm going to compute like, let's say, 1,000 transactions as Starknet, and then the cost of these transactions on Ethereum layer 1 is $1. So Starknet is going to limit this for you and say, okay, they are going to divide $1 by the whole 1,000 people, right? So let's divide $1 by 1,000 people. How much is that going to be? Let me try.
That is 0.001.
Perfect. So that's where you see the transaction cost gets cheaper now. So instead of we running like, let's say, each person come to a transaction for $1. Why not give up this transaction? Let's compute it off chain for you. So Starknet will now compute 1,000 people's transaction, right? And then just send it as one to Ethereum. And then the cost of that transaction, if it's $1 on Ethereum, Starknet will distribute that $1 to the whole 1,000 people. And that's why the money will not turn to be $0.00001 at the end of the day. Do you understand the logic? Hello, Chinonso.
Yeah, I get it. I get the logic. So, but Starknet, I think, is not the only layer two. So you're not trying to say that other layer twos also help in reduction of gas cost.
Yeah, yeah. That's true. Now there are other layer 2 solutions, right? And then all these ones, they came up with their ways of how to bring in or how to make cost cheaper. At the end of the day, all layer 2s are trying to achieve scalability, which is reducing gas cost and then improving the speed of transactions. That's what all layer 2s are trying to.
I got you now. I got you.
But then all you have to do is look underlining the tech of each of these. Can you hear me?
I am hearing you. I'm hearing you very well. Loud and clear.
Perfect.
Loud and clear.
We are not going to say they have security. They rely on security, right? So look at the tech of all of these layer tools. So that's why we're discussing about Starknet today. And we are going to jump straight into like the. Oh my God. Please, are we in sync in this class? I really want to know. Perfect. All right, so let's continue. So we're going to look at the architecture now of Starknet. So when you want to do anything with any hello guys.
Yeah,
hello.
we can hear you. We can hear you.
Okay, my network is breaking, right? Like I'm experiencing that. So but then let's continue for now. Yo, hello everyone. Nice. So I just quickly switched my network. I'm experiencing issues with my router, so I just switched back to my phone. I'm very sorry for that. Okay, so let's proceed. So I hope Chinoso was clear, right? And then you understand how all these layer tools are able to do this. So that we'll jump into Starknet.
Yeah, I was clear. Very clear.
All right, cool. I think we had one more question, right? Or should we just proceed? Let's take it. Or let's proceed. So we'll look into that like properly. So that's why I want us to go into the architecture. I get you victory. So we'll look into the architecture and see if it can happen. Let's see how Starknet achieved it. Cool, I get you. All right, so let's proceed now. So the slide was saying something. It says Starknet achieved this in its use of some cryptography called stacks. So we all understand what cryptography is, right? For those of us who have done Ethereum already. So it's just a branch, cryptography is just a branch of mathematics that is used in the blockchain, mostly to generate proofs and or to create hashes. So this is how Starknet achieved this with cryptography called stacks. All right. And then I said Starknet is a validity rollup. So now, to the guy who asked about the two different, or I said two different, the guy who asked about the other layer 2 solutions, I told you all layer 2 solutions are trying to achieve scalability, right? Different type of layer 2 solutions. So everyone is coming up with his own way that he feels he can do it better, right? So let's look at the different ways that they do it. So popularly known, there are two types of rollups. So rollups are another name for layer 2s, right? So you can also call them rollups. So there are two types of rollups, namely the optimistic rollup and then the validity rollup. And then each of these rollup have a way that they achieve scalability, because at the end of the day, all they want to do is achieve scalability, right? So optimistic rollup, they work with what we call fraud proofs. So fraud proofs in the sense that transactions are being submitted and then they take a period of time to vet these transactions. And then if any fraud proof is being generated for that particular transaction, the transaction is going to get rejected. But if there is no proof or fraud proof that is being raised for that particular transaction, then the transaction is being accepted on the L2 on the So the transaction is being accepted on the L2, right? And then it's being processed. If the fraud proof is being sent for that particular transaction, that means maybe it's a fraudulent transaction and then it's going to get rejected. But if nothing gets sent within the period of time, maybe let's say popularly they use, let's say 7 days, it takes about 7 days, some I think 3 days or so. But let's work with 7 days. So within 7 days, if no proof is being raised that this transaction is a fraudulent transaction, it is being sent to layer 1. But then if a proof has been raised that this transaction is a fraudulent transaction, it gets rejected, right? So that's the solution that optimistic rollup came up with to be able to achieve that. Secondly, we have validity rollup, like Starknet. So what they do is that they take this transaction, generates a proof, and then at the end of the day, they send this proof to the L1. So on validity rollups, it checks immediately, and then it takes about 6 hours, 7 hours, even as less as 3 hours, right? Easily using zero knowledge proof is going to verify that, hey, this transaction is valid, and then is going to fully send it on the L1. So Starknet work with stacks, which is it doing some basic mathematics at the end of the day to verify that, yes, this transaction happened off chain, and then it sends it onto the L1. And then the process of doing all those mathematics to prove this takes less than, let's say, 7 hours max, or even less, right? For it to get accepted on L1. So we are going to look at also the transaction life cycle on Starknet and then see how long it takes and understand how all this flow goes, right? So that's the type of rollup that Starknet is, a variability rollup. So next up, sorry guys, my book just got closed. Let me open it. It has all the bullet points I want to talk about, and then all right, cool. Just saw it. So the Starknet architecture, right? It's not on this slide. So I think let me just head over to like where can I draw? Can I get like a board online? So let me just draw the architecture. So later on, I'm going to be sending these slides directly for the base camp, and then other stuffs you can check out. Oh, does anyone know any I can use? You can just send me the link in the chat so I make use of it to be able to draw the architecture. Oh, nice, draw.io. I think these were the guys that were pushing me off, or I just tried to check it out. I think I can see it in the Starknet website, right? I think I can see it there. Yeah, just hang on. Let's just open up. So we can have a look at the architecture while the Escali draw opens. So, but before then, how does Starknet works? I told you guys that it takes this bunch of transactions, right? And then bundles these transactions together. And then at the end of the day, it sends the transactions to the L1. So there are three main guys in the Starknet architecture. Number one, the sequencer. So you guys should take note of that. The sequencer is a very strong guy that helps in achieving scalability. Next is the prover, another very important guy. And then next, the verifier. Perfect. So these are the three main guys that do like the whole bunch of work, right? These are the three main guys that do the whole bunch of work. Now, this is the work of the sequencer. So first and foremost, the sequencer is the guy that collects or takes all these transactions together. So all the transactions that are going to be collated and going to be run off chain, the sequencer is guy that is going to be responsible for all these transactions. Now, how does it do that? Like the name implies, sequence, right? Sequencer, got it from the word sequence. So what it does is that it takes this transaction one after the other and arranges them in sequence, and then bundles these transactions together and then send them to the prover. Good. So if you have worked on Ethereum before, you are going, the first thing that happens on Ethereum is that this transaction gets submitted to the nodes, right? And then this transaction don't get accepted sequentially on Ethereum. Do you agree with me? Or is anyone with a counter order? If you agree with me that transactions are not taken on a sequential node in Ethereum, let me see your emojis. Hello? All right. So the transaction has been submitted to the node, and then these nodes at the end of the day, they don't take this transaction sequentially. They do this transaction by preference, right? Hey, who has the highest gas fee? And then I'm going to verify his transaction first because the network is slow, and then we take priority to the, and then we have bought expensive gadgets. I'm putting a lot of funding, about 32 ETH to be here. So we need you guys to pay higher money, right? So the guy with higher fees is going to be the first guy accepted. That's what happens in Ethereum. So if you're in Nigeria, you understand me properly, right? Good. So, but in Starknet is not that way. What happens is that it accepts these transactions sequentially, in sequence. So if you are the first guy to come, you are going to be the first guy to be accepted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Until it gets to, let's say, 1,000. Takes that whole 1,000 and then sends it to the prover. So that's how the sequencer works. So now it's not a matter of money. Just come and then you get accepted, first and foremost. So if that's just the simple job of the sequencer, to take these transactions and then to send them to the prover. Simple job, right? Next is the prover. What is the work of the prover now? So the prover takes all these transactions and then generates a proof that this transaction have been computed, have been vetted, and then they all exist, or they are all good or perfect transactions, right? That can be sent to the L1. So that's just the work of the prover. It's going to prove that all these transactions have been computed off chain, and then they have all passed the test, and then they are good to go and can be submitted on L1. So instead of it doing the job of who now? The Ethereum node. That stress of the Ethereum node. The prover will help the Ethereum node ease the stress and say, hey, I've done this thing. No need for you to verify it again. This is a proof that I have done it. Just keep it at the end of the day, right? That's just the work of the prover. So in simple terms, who are we going to explain a prover is? Have you been to, like, let's say a personal assistant office or so, or the governor PA, or something like that? So instead of the governor, everything to go through the governor, and then the governor is going to have a lot of stress, and then the whole about 2 million people are going to be on the governor's head. What the governor can do is just say he's going to have like how many special assistants or how many people that are attached to him, that all these things are going to be laid on them, right? So instead of 1 million people or 1,000 people coming to the governor direct, each of them have like sub people that they can meet and talk to first before they lay all the information to the governor, and then the governor is able to solve it. So that's what the prover does. Look at the prover guy, like that PA guy or that SA. So it takes all the transactions, generates a proof that all these have been computed off chain and they are good to go. And then it sends the transaction at the end of the day to the final guy, who is the verifier. Now, there are two things we need to understand. The sequencer and the prover, they both exist in the L2. That's where both of them exist. The sequencer and the prover both exist on the L2. Then the verifier exists on the L1. Because somebody will say, okay, Starknet is saying they are scaling Ethereum. How? How will Ethereum agree that yes, Starknet is scaling them? Or are we going to say that Starknet is leveraging on Ethereum security? There has to be an interaction between the two, right? Before we can agree that yes, our transactions are fully computed. Yes, we went through a scalable means, and then at the end of the day, we are being secured, or our data is being secured on the blockchain. There has to be an interaction between the two. So let me go back to this simple analogy about the PA guy and then the governor I was talking about. So imagine you sending your file to the PA, right? And then the PA receives all your file and doesn't submit it to the governor, what will happen at the end of the day? So it's like a job done equals to 0, right? And then nothing is being achieved at the end of the day. Good. So the prover guy is the PA, and then imagine he receives your transaction and doesn't give it to the governor. So there have to be an interaction between the two. In this case, the governor is the L1, and in the other case, the PA is the L2. Because the PA, you and I know that the PA are easy to see. You can meet the PA in the restaurant or maybe somewhere close as fast as possible and see the PA. The PA might even be your friend, and you can easily give him the information, right? That's what the L2 does. But then the governor is like the L1 that the PA will relay this information to. And then that is the verifier. So there's a verifier that lives on the layer 1. That's where the interactions come between the two. The verifier lives on the layer 1, and then the verifier is just a smart contract at the end of the day, right? And then the prover is going to send this data to the verifier. And the verifier will verify that, yes, the verifier is also going to compute it. And then say that, yeah, this transaction, yes, it exists. And then the proof is valid, right? The proof that has been generated off-chain is set on-chain and then being verified on-chain. And after being verified on-chain, if the proof is correct, yes, this data is now being accepted on layer 1 and then is going to be sent at the end of the day to the Starknet core contract. So there's something called the Starknet core contract on L1. That's like where everything is being saved. So sends the proof to the core contract, the proof saves the core contract, and then your transaction lifecycle is complete. And then we say accepted on L1. Now your transaction that you just done is fully, you did it in a scalable way, and then in a decentralized way also, and then finally it is being secured on the L1 with layer 1 security, and then we are good to go, right? So that's just how the Starknet architecture looks like. I'm still experiencing issue with my network. That's why I'm clicking this is not opening, but I'm supposed to see it on the Starknet website. Yes, this there, right? But then when I click on this, it doesn't go through. Meaning my network is really bad, and then it's just keeping me on the call. But can you guys hear me? That was important.
Yes, yes, yes. We can hear you.
All right, cool. So let me proceed. So next thing now, let's look at the transaction lifecycle. So I've talked about a lot of English. I think the best thing to do is to talk about the transaction lifecycle. But before we talk about the transaction lifecycle of Starknet, there are two very important wallets on the Starknet ecosystem, which are the Agent and Bravos wallets. So currently more integrations are still coming in, but then the main Starknet wallet is Agent and Bravos. But then there are other more coming in, like Klepta, who recently is integrating, and then MetaMask too. Something is also coming up whereby interactions can be done through there. So via Agent and Bravos, we can be able to successfully see the Starknet transaction lifecycle, right? So let's see how your transactions move from the verifier to like the prover and then finally to the L1. Let's see what it looks like. So for those of you who haven't built on Ethereum before or any blockchain, there's what we call wallets, right? And then wallets are your gateway to the blockchain. So simply put, on Web 2, like our normal apps like Facebook, we can easily access Facebook using our email and password, right? That's our gateway to our Web 2 apps. Some don't even have any validation at all. So you just need your laptop and then there's no authentication at all. But then the blockchain is a blank box. And then to access the blockchain, you need your private keys, right? To sign transactions. All of us are going to agree with that if you have worked with the blockchain, right? And then your public keys. So, and then the gateway that helps the what helps you manage your public and your private keys is your wallet at the end of the day. So that's why it's your wallet. You can be able to sign transactions. You can be able to see your public key at the end of the day. That's just what wallets are for. So let me just head over to, let me use the Bravos wallet. And then let's run a very simple transaction and have a look at how it goes from where to where.
And sorry, you are not sharing your screen.
Yeah, that's what I'm trying to do. And I think, okay, yeah, good. It wasn't coming on. So hang on a little. Can you see my screen now?
Not yet. Okay, yeah, it's coming up now.
Oh, perfect.
Yes.
So just help me pin it so I can.
Yeah, we can see your screen now.
All right. So first things first. So this is my Bravos wallet. We are going to talk about that later and then send you guys link. You can just check it out like your normal extensions, right? On Brave or Chrome, and then install it and use it. You can also install it from your mobile, right? But let's work here first. So you can just head over and search Bravos or Agent Wallets and then install their extensions, and then you are good to go. So we walk through the steps. But then first and foremost, let's look at the transaction life cycle. Or should we try to set up a wallet first? I think that would be better before we even look at the transaction life cycle. Nice. So I don't have a wallet in my Chrome, so I'll just go back to Chrome, right? Good. But then I've installed Agent already. Well, let me just try to search it and then show you guys. Yeah, so you can just check it on Chrome, like your normal extensions that you install, right? And then you add it to Chrome, and then you're good to go. So if you add it to Chrome, yeah, so this is my wallet. So Agent's asking me to create a new wallet or restore an existing one. So I'll just click create a new wallet. So this is them asking me to help do this. But no thanks, I won't. Or how do I do? Should I click agree? No. Okay, so new wallet, enter password to protect your wallet. So let me type a password. I hope you guys can see that. So if not done this, just head over and do this now. So Agent wallets, I would say they are the grandmasters of account abstraction. So they have amazing features like 2FA and a lot of things, right? So you can read about this. And then this is just for smart accounts. So every account on Starknet is a smart account. So let me explain that for you. If those of you that have worked on Ethereum, they are normal EOAs, which are externally owned accounts, right? And then the process of getting this externally owned accounts is through some cryptographic way that goes through, let's say, the ECDSA to generate your private key, and then it heads over to generate your public key, and then finally it generates your wallet address, right? So that's like the process of having an EOA address. But then on Starknet, every wallet is a smart wallet. So how is it a smart wallet? If it's simply put, every wallet is an a smart contract. That's just what it is. So every wallet on Starknet is a smart contract. So for those of us who has gone through Ethereum before, there you popularly known the ERC 4337, right? Is that the account abstraction EIP? Somebody should remind me. Let me see whether I still remember. Oh, okay. I think I'm correct. All right. So ERC 4337 is the concept whereby account abstraction came in, whereby smart contracts can be wallets, right? Which it can have plenty features. So if a smart contract can be a wallet, meaning we can write a lot of external functionalities and then make it properly better and sweet with proper UX, right? That means it's going to be flexible and we can create our wallet the way we want it. So that's just ERC 4337. But then there are three most important things that must be implemented, right? We need to know whether it's a valid signer, and then it needs to run the execute function. So the execute function is just a function that can help you run other functions, right? So that's just what account structure is all about. For those of you who haven't done L1 before, I would advise you go through and read that while reading through smart accounts too. So that's the same concept in Ethereum. So I said Ethereum, Starknet. So smart accounts, they are just smart contracts, but then they behave like normal externally owned accounts. So the user has the right to sign transactions, have full custody of this wallet, run normal transactions like an EOA, send money from one place to another, and then even have external features and more sweet and unique features, which make them better and improve the UX of Web3. So that's just what smart wallet does. And then a wallet like Agent is a smart wallet, right? So it gives us stuff like 2FA, which is two-factor authentication, which works specifically with your email, right? So 2FA is as easy as you having an extra layer of security to sign in, let's say, transactions on your wallet or even accessing your wallet. So instead of a user accessing or signing transaction directly from your wallet, once he signs the transaction, something extra can be added that the user has to provide before the transaction is going to go through, right? Which is probably can be your face ID, can be your what now? Your thumbprint, can be an external uh, password, can be a hardware device, maybe a particular, you know, maybe let's say your device holds like the key. If it is not being signed from your particular device, it's not going to go through, right? Or probably it's not going to get recovered. That's just some of the external features that this brings out. So let me see, but I have an account and I would not love to use my email again. So let me just create a standard account. So I hope we are still together. Let me see your emojis. If you are already trying to download Agent or if you already have Agent, right? Emojis, please. Nice. Yeah, I think someone is raising up their hand. But let's just check if our wallet is done. Okay, so you can also follow Agent on X or join the Agent Discord channel, which I have. Or if you haven't, I advise you do. Right? So I think my wallet is set. And then I'm good to go. I have 00. And then this is my wallet address, wallet address. I can also see my recovery phrase, which is very important. I can review this and then copy it and save this, right? No matter what, this is like the main guy on Starknet, right? I say Starknet on every wallet. Your seed phrase, you keep this. But then with um smart accounts, there are brilliant ways that you can even do account recovery, right? So you've seen where people have lost money simply because they lost their private key or access to their wallet, right? But then on smart accounts, there's account recovery, which can be done. So, but then you need this recovery phrase. Very, very important. And then just of recent that I think agent integrated importing with private keys. But I think there's a you guys. I'm sorry, guys. It's just lost my network again. So nice. So can you all see my screen now? All right, cool.
Yeah,
All right.
we can
So
just
let me just try to make a transaction here. All right. So here in my Bravos wallet, I will just switch over to. So this is my Bravos wallet that already has funds, right? Or let me just try to collect first. No, I want to see transaction life cycle. So I'll do it here. All right. So let me just get yeah, let me just switch to my Sepolia wallet. Yeah, so this is my Sepolia network where I'm a rich man. So all right. back to my agent, right? Which is here. Let me switch my network to what now? Sepolia. So continue. Good. So back to this. So let me transfer, right? And then paste this wallet. Then let me just transfer 0.1 stack. And then let's see. So can you see this is the estimated gas for this transaction 0.001. This is the cost. The estimated transaction is this $0.001, which is 0.0024 stack for a transaction. So in the Starknet ecosystem, the stack token can be used for paying of gas fees, right? So that's one thing that makes Starknet stand out with some other validity rollups. I say validity rollup with some other layer 2 scaling solutions. So some use Ethereum, but then on Starknet, you can use the stack token for your transactions, right? So let me just hit the transfer button and then I proceed to send funds. And then my token has been sent as fast as possible. And then let me head over to view the transaction in activity. Oh, good. So that's the transaction. So let's head over and see if we have it here. Yeah, I think we have 0.1 stack here on L on this, right? Perfect. So we are here right now. We are good to go. So this is the transaction life cycle of how your transactions move on Starknet. It goes from not received to received, and then pending, accepted on L2, and then accepted on L1. So now this is the process. First and foremost, when your transaction is being received by the sequencer, it moves. Finally, when it's being verified, or when it goes to the pending state, it means they are being collated, right, and being gathered together to be sent to the prover. And then finally, when it gets to the prover, and then the prover generates a proof, that's where it hits this accepted on L2. And then lastly, when it gets to accepted on L1, it simply means that all the transaction has been collated and then sent to the layer 1, and then it has been received by the verifier, and the verifier has verified it, and then it has been stored on the Starknet core contract. That is where the transaction lifecycle of Starknet goes, right? So as you can see, from here to here takes milliseconds. As soon as I do it, few seconds, as soon as I do it, it just goes through. It shows you green, 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 meaning, yeah, it has been, the sequencer has gotten it, it has proven it, and then it has accepted it on L1. But then for the prover to send it to the verifier, it takes 3 hours, 42 minutes, and like 16 seconds. So this is the countdown now for my transactions to be accepted on L1. So that's how long it takes for my transactions to move from my verifier from my prover to my verifier for it to be accepted on L1, and then it's fully complete. So roughly, remember before I said about 7 to 6 hours, 6 to 7 hours, but then as you can see directly from Stack Scan, I can be able to see that it takes like 3 hours plus. So that's that less than 4 hours. And then my transaction is fully going to be verified. While on an optimistic rollup, it takes 7 days, 6 days. So which will you go for? Are you going to go for the guy that takes just less than 4 hours to get your transaction on L1 and fully secured, or the guy that is going to take 7 days with your goods? Now, remember, let me ask a simple question in this term. Are you going to prefer to give a delivery guy that will take 7 days, or the delivery guy that will take less than 4 hours to get your items across to you? Who are you going to give the job to? If you answer that, I'm going to know which L2 you are going. Less than 4 hours. Perfect. So meaning everybody is going with Starknet or the validity roll-ups. Is there any opposition party here? Perfect. There's none. So we can proceed now. All right. So that's how the Starknet transaction lifecycle goes, right? We've seen that on here, right? That's how the transaction lifecycle goes. So next up, by the end of this class, your assignments will be to do all of these installations and then get yourself fully ready, right? As a dev or as a Starknet developer. So next, now let's since we have installed our wallet now, how do we get our faucets? So simple question, right? So currently now, what's going to happen is let's head over to, let me check in. I think I have it here, Starknet faucets. So this is where you get it easily, right? So on Ethereum currently you need like some amount of money before you can be able to. Wow, I think there's a problem with my VPN. Oh my god, yes, that's it. That's why some things have not been opening. Let me just disconnect. Good. So you can request your tokens here, right? And then you don't need all those money for you to be able to get your tokens up here, right? At all. You don't need anything at all. You don't need some amount of cash on mainnet. All you just need is to come over to starknetfaucet.vessel.app. And I think you can also get it from Alchemy, right? But then you need some mainnet money. Let me send this over in the chat so that those of you that want faucets can just head over to get it. So you just insert your Starknet address here. And then, so let me put this my address. And then stack. So I can receive 20 stack every 24 hours. Whoa, I think they've changed this. Whoa. A lot of people are collecting our tokens now. They've changed this. You could do this before in every 60 minutes. But I don't know what's happening. So you can either collect stack or ETH, because you know you can use both for signing of transactions, right? So mostly I like choosing ETH, right? But then just go with stack, because at some point you need some few stack, some few ETH, because transactions on Sepolia, they might demand more stack from you, but with ETH you can run more transactions. That's just a cheat code though. When you are building, you understand. But our main aim now is just to collect these tokens. So we can just verify we have a success and then we request for these tokens. So let's have a look if this have come true. So if this have, we should see about 20.1 stack here. Oh, are you sure I put the right address? All right, so no need. I don't think I need that, but that's just how to get these tokens, right? So we are good to go. Is this? Yeah, so it's here. You can see 20.1 stack. Then I have it here and I'm good to go. So up next, let's talk about the language for building on Starknet, and then have an overview of the syntax. And finally, we can talk about a program structure of a Cairo program, and then we are good to go for the day. So most importantly, Starknet, to write smart contract on Starknet, we use a programming language called Cairo. We use a programming language called Cairo. So for those of you who have been working on Solidity, Ethereum, you already know that the smart contract language for programming on Ethereum is what? Is Solidity, right? But then on Starknet, the programming language is Cairo. So first and foremost, what is Cairo? So I think it will be best if we just head over to Cairo and look at the Cairo. And then let's see what the Cairo programming language is. So I will also send this. I'll send this in the chat so that we all can access it. And then we are good to go. Okay. All right. Does someone has a question? Yeah, so let's proceed. So that's the Cairo book, and then you can all read through it. So first and foremost, what is Cairo? So Cairo is a programming language designed for a virtual CPU or the same name. So Cairo stands for, a lot of people will say, is a, when you first search on Google, it's going to show you Cairo of Egypt, right? So before you say Cairo programming. So how did they come up with the word Cairo? So Cairo stands for, so the C stands for CPU. That's why they told you Cairo is a programming language designed for a virtual CPU, right? So the C stands for CPU. The A stands for air, right? AIR. So CPU, I think this, I need to check this out. I think it's arithmetic intermediate representation. Oh, magnificent. Yes. Yeah. So that's where they got the full word Cairo. So C stands for CPU, then air, then the air is I think Can you just permit me to check this out? I think that will be better. I'm stuck between arithmetic and algebraic, so I don't want to give the wrong one. Uh, so while it opens, so then this is the logic. So in Solidity, your Solidity code breaks down to byte code at the end of the day, right? And then the EVM is simply going to understand that. But then on Starknet, Cairo breaks down to Sierra, and then Sierra breaks down to Kazim. So Kazim is what the Cairo virtual machine works with, right? So on Ethereum, it has an EVM, which is an Ethereum virtual machine, right? And then the EVM understands bytecodes. But then Cairo has, Starknet has CVM, which is a Cairo VM, right? And then the Cairo VM understands Kazim, which is Cairo assembly. So initially, while there was Cairo 0, so Cairo 0 used to directly compile to Kazim. So if you write your Cairo 0 code, it's going to compile down to Kazim, and then this is going to understand. The Cairo virtual machine will understand. But then in Cairo 1, it first compiles to Sierra. So Sierra is the intermediate representation person, right, of Cairo. So compiles to Sierra, and then from Sierra, it compiles down to Kazim. So Sierra stands for Safe Intermediate Representation, right? So we understand why they brought all those concepts and why they are there later on. But then just know that Cairo, or the EVM, it has to break from Solidity, it goes to bytecode. From bytecode, at the end of the day, it gets to become the EVM understands. But then in Cairo, no, it breaks to Sierra first. And then from Sierra, it breaks down to Kazim. And then for Kazim, it goes down to the Cairo virtual machine, and the Cairo virtual machine is simply going to understand. So there's a method, there's a reason why they brought Sierra later on. I can explain that, but it's very lengthy, and then it's going to take like a whole lot of our time, and we might deviate from the class. But you can easily understand the difference between Cairo 0 and Cairo 1. It's not just because it's Python-like. Because a lot of people will tell you Cairo 0 is Python-like, and then Cairo 1 is Rust-like. So they didn't shift from Cairo 0 to Cairo 1 simply because they didn't like Python, or simply because they want to look like Rust. It's simply because they were trying to achieve this Sierra guy. That's why they moved to Cairo 0, right? So it's easy. Cairo 0 compiles to Kazim, but then Cairo 1, it first go to Safe Intermediate Representation first. And that's simply because Cairo wants to know, hey, which it is going to account for the failed transaction and also transactions that went through, right? So initially in this Cairo 1, it doesn't cater for transactions that fails. It only knows transactions that were successful and go through. But then this Sierra is to know the transactions that also went bad and also the transactions that went through, right? That's why they brought this safe intermediate representation. And then finally, it goes to Kazim. So they can account both for failed transaction and also for successful transaction. All right, good. So they will explain it down here. So they say the point of Sierra is to ensure Kazim will always be provable, even when the computation fails. Perfect. So that's why they brought it. Right? So even though the computation fails, so even though it's failed, Sierra will ensure that Kazim is always provable. So that's Cairo for you. And then I will advise you head over to Cairo, read all over this introduction, know why Cairo is different from other programming language. And then I'm going to be highlighting a very little point why Cairo is different from other programming languages, right? So in simple time, a lot of people will say, why create Cairo, a Rust-like programming language? Why not just write Rust? Right? Why create Cairo? Why not just write Rust and use it to write programming, write smart contract language? At least a lot of blockchains are using Rust, right? Or blockchains like Solana are using Rust. So why not just use Rust? Since Rust is going to work, why choose Cairo? Or why not another programming language? So why not Solidity? Since they say they are scaling Ethereum, why not just stick to Solidity, right? Why did they choose to bring Cairo? So in simple terms, Cairo is a programming language that generates proofs after computation. So take, for example, if you are working with a programming language like Rust, it's successfully going to run the computation for you, but it doesn't generate a proof for that particular computation. Why do we need a proof after running a computation? A very easy question now. So why do we need a proof? Simply put, let's take, for example, we are going to war, and then our counterpart is another country. And then those country are the country that built, like they wrote the programming language, that's where our compiler exists. And then at the end of the day, it's their server that we are going to use to compile like the whole um, of our transaction. Let's say we have a transaction that we want to run, and then the transaction is to launch a rocket to our counterparts or to our enemies. Let's launch a missile to our enemies. And then we successfully wrote the code. But then the problem here is, after writing the code, it is our enemies that are going to do the computation for us at the end of the day, right? So it's very funny. It's just like you are telling them that we are saying that they should kill themselves. So we wrote the code, and then now they are compiling it, and then while compiling it, they saw that these guys are trying to launch a missile at us. What are we going to do? So what do you think that our counterparts are going to do if they see that we are going to are going to launch a missile for them? And then this missile we are trying to launch is going to, before it gets launched, it has to be compiled by their own server, which lives in their country. What do you think they are going to do? Let's hear honest suggestions. But we can just move on because we all know the answer. It's simply not going to be possible, right? In short, they might end up even changing the coordinates against us. And then while we launch the missile, it's going to launch maybe to our president's house or something. And then that's very, very bad. So that's what other programming languages do, like Rust. So when you do your whole computation, another person will do the computation for you and then send it back, and then you just execute. You just execute. You don't care. But with programming languages like Cairo, when we send those what we've written and they compute it, it's going to generate a proof for that particular computation. And then while it is sending the result back, the result is going to come with that proof, which can be run by us. And then we are going to verify that, yes, this computation that these guys ran for us is correct. And then we can proceed with this data because they can alter it simply because they are the guys doing the computation for us. Right? But then with programming languages like Cairo, you don't have to worry, because when it sends a proof back, if you run the proof locally and the proof is not valid, meaning the computation was tampered with. So you are not going to head over to run it. And then you are in a safe space. But then in other programming languages, you don't have a proof that this computation is correct. You are just working like a blind man, collecting it and just running it. And then you might end up shooting yourself in the leg, right? So that's one thing that Cairo does, and that's what makes it stand out with other programming languages. So you all can read this, understand what Cairo does, but just know it is the language for writing smart contracts on Starknet. And then another advantage of Cairo over Solidity is that Solidity is specifically built for smart contracts, only for smart contracts. So aside the EVM, Solidity doesn't exist, right? But then Cairo, you can use Cairo to write Cairo programs. And you can also use Cairo to write Cairo contracts. So you can build your normal programs with Cairo, and you can also write your smart contract with it. So this is enough advice for you that you can build a full career with Cairo, right? And then you're good to go. So you don't have to worry about, though currently you don't support some other stuffs, but just know that you can write your programs with Cairo, right? And then also smart contracts. So that's you writing, using one stone to kill two birds. Learning smart contract language and also learning a program language, right? And then you are good to go. So that's just a basic introduction to Cairo, and what the language does. I don't think it will be a safe time today because we are far gone to do like the installations. I said installations to see like how the syntax looks like. But maybe next class we can have an overview of the Starknet syntax, right? And understand how the syntax work. Or it can also be an assignment for this. But lastly, let's just check. Oh yeah. So head over to Cairo book and also head over to, let me check this out. Let me check the Starknet book. That's another good location to start with. So let me send you guys the Starknet book. And then we are good to go. Thought I was going to see this here. All right, guys. So this is Starknet book. Wait, is it? This is the docs. This is Starknet documentation. Still, yeah, this is the book. Good. Sorry for that. Wow, this has been archived. That's serious. Ooh. So this has not been maintained, meaning this is not the best place for us to be right now. So they are advising us to head over to the official documentation. Yep. And then this looks good. So let's just work with the documentation and then we can work with this. Wow. So let's work with the docs since the book has been archived. You can check out the quick guide that will teach you how to set up all your environment as a developer, right? So there are certain things you need as a developer. I think it's going to be too quick for this class, but we'll just run over them a little, right? So that you people can have them installed in your laptop even before we get there. So you have to install, these are the tools you need. Starknet. So Starknet is a command line interface that allows you to interact with Starknet. So if you have Starknet, you can be able to deploy contracts, declare, make those contract interactions using with Starknet, right? Good, just a CLI tool. And then secondly, we have Scab. So from this, you can click all of this. So secondly, we have Scab. So Scab is a tool chain or a package manager for Cairo and Starknet ecosystems. So if you have worked with Node.js, Starknet is like npm to, and Scab is like npm to Node.js, right? That's how Scab is like the way Scab is to Cairo. That's how npm is to Node.js. And then or React. And then for those of us that have written Rust, Scab is like Cargo, right? Which is a package manager. So that's just what it is. Then lastly, this amazing framework that we all might end up finding ourselves using, Starknet Foundry. So Starknet Foundry is a framework for building testing smart contracts, right? So with the Foundry, with Starknet Foundry, we can have access to stuff like SN Forge, SN Cast, which can help us also make interactions to this Starknet contracts and stuff, right? So if you have this Starknet Foundry, you might not be needing this guy, but you might install this guy. Maybe you want to do some stuffs, right? So I would advise you have Starklight and Starknet Foundry together so that you will determine which you want to work with. So this is the installation process. You all can work towards it. You can do this, or you can set it up using ASDF like that. Install your Starknet Foundry, and then in subsequent sessions, we are going to learn how to work with all of this. So this is a nice overview to get started with. And I believe with this, we can start setting up and we are good to go for the remaining course of the week. So the main course of this class is just to like water the ground and for us to understand what we are going into, right? So next up, let's set up and then get lock and load, and then we are good to go. So we'll be stopping here, and then I'll be taking questions, and we are good to go. So let me hear from you guys.
And yeah, Lucas, thank you very much for the wonderful session, right? So it's time for questions now. If you have any question, please just raise up your hand and the floor will be yours. Any questions so far, please? Okay, I think there's no question from anybody. The online guys, can you guys hear me?
Can hear you.
Okay, nice. So I will create a Starknet group on Telegram, right? So for your, maybe you have questions and later on you will just let me know, and I will, you will just drop on the group chat. So just message me your and message me on WhatsApp, right? I'll drop my number on the chat box. So just message me on WhatsApp so that I can add you to the group. Yeah, thank you very much. I think that'll be all for today. And Manuel, I don't know if I have any assignment for them.
Yeah, so we have a very simple assignment, and then the assignment is just head over to the Cairo book, head over to the Starknet documentation, start getting used to it, read through properly what we've talked about. Then also head over to the installation guide and start installing like some of these stuffs. that we need. And then get your faucets, your wallet ready. If you have not installed your wallet, make sure you do that, and also receive test tokens. So as soon as you receive these test tokens, I would like you to make transactions too, to have a look and feel of how it works on Starknet. I think that will just be all for now, since this is our first day, just to get ourselves started, so that before Wednesday we're already good to go, right? And we're ready. So that's just it for now. Do we all get the assignment?
Yes.
Perfect.
Yeah. They all got it.
Yeah. All right.
Okay, I think that'll be all now. Thank you
Any
very
other
much.
thing, you can also reach out to me also, and I will be there to reply
How
you.
can we reach out to you? How can we reach out to you?
Twitter, WhatsApp. So Twitter is perfect. Just send you
WhatsApp
my.
will go.
I'll drop his details on the group chat.
So that's my Twitter. You can check me out, and then we are good to go. All right. So bye, guys, and see you next class.
Yep. Bye. Stop recording.